Hello everyone, in this video we're going to pick up where we left off in section 10.3 with example 4 here. So let C be the curve given by x equals to 5 plus ln of t minus 2 and y equals to t squared minus 1, and we want to find the equation of the line tangent to C at the point corresponding to t equals to 3. Right, so again, in order to find the equation of that tangent line, we need a point, we need a slope. We've got a point because we've got t equals to 3, but we need to find the slope. Right, so in order to find the slope, we need dx dt, or the derivative of x, which in this case, in order to find this, we're going to need to do the chain rule. So the derivative of 5 is 0. The derivative of ln of t minus 2 is 1 over t minus 2. And then chain on the derivative of t, which is just 1, so it's just 1 over t minus 2. Then the derivative of y is going to be 2t. So what does that mean? That means dy over dx, by definition, is dy over dt over top of dx over dt. So it ends up being 2t over top of 1 divided by t minus 2. Instead of dividing by 1 over t minus 2, I can multiply by t minus 2. So I get 2t times t minus 2. So I get 2t squared minus 4t. Right? And so now we can find our derivative, but actually in this case now we need to find our point, right? Because in order to write this, in the earlier case we were able to know that that point happened at the y-intercept 2, because it was the point 0, 2, but in this case we don't have that luxury, so we actually need to find our point. So let's find the point corresponding to t equals to 3, right? So if t equals to 3, then x is equal to 5 plus ln of 3 minus 2. So I get 5 plus ln of 1. Ln of 1 of 0, so I just get 5. And then for y is t squared, so I get 3 squared minus 1, so 9 minus 1, which is 8. Right, so my point is 5, 8. Now let's find my slope corresponding to t equals to 3. Then that's going to be dy over dx, and we found that equation to be 2 times t, which is 3 squared, minus 4 times t, which is 3. So 2 times 9 minus 12, so 18 minus 12, which is 6. So I have my slope and I have my point, right? Point slope form is how we're going to write this equation of a line. Remember, in general, this is y minus y1 is equal to mx minus x1, where x1 and y1 are my point and m is my slope. So I get y minus my y value, which is 8, because I found my point to be 5, 8 is equal to my slope 6, x minus my x value, which is 5. So let's go ahead and put this in slope intercept form. So 6x minus 30. So y is equal to 6x minus 22. So that's going to be the equation of my line tangent to the graph at t equals to 3. So in general, remember that my derivative looks like y over x, the derivative of y over the derivative of x. So if my derivative of y is 0, then that means that my whole derivative is 0. So that means that I have a horizontal tangent, right? When my slope equals 0, I know that I have a horizontal tangent. If dx dt, that means my denominator of my derivative equals to 0, then that means my slope is undefined, which means I have a vertical tangent. If both x and y, then I can't make a conclusion about tangent lines. I have to do more work, such as graphing it. Okay, so now let's talk about arc length in parametric form, right? We know in general how to do arc length, right? It was s equals the integral of 1 plus the derivative squared underneath the square root, right? So now how do we do that in the parametric form? If a smooth curve C is given by x equals f of t and y equals g of t, such that C does not intersect itself on the interval from A to B, except possibly at the endpoints, then the arc length is, it looks like the x derivative squared plus the y derivative squared all underneath the square root, right? And it's derived from that formula that I just wrote above. Okay, so now let's look at this example here. A circle of radius 1 rolls around a circumference of a larger circle of radius 4, right? So think about this guy as my larger circle of radius 4, and think about having a quarter, right? Say I have a quarter right there, and what do? I put a dot on that quarter, and then I roll that quarter all the way along this whole circle. As I roll the quarter, that dot keeps moving all the way around, right? As I move it along the edge of that big circle, right? So that's the idea here. And then our goal is to find, or I guess our goal here is the epicycloid traced by a point on the circumference of the smaller circle. So this, the curve that gets made is this with all these circles here. And it would keep going, and it would look like this four-leaf clover type thing, right? So if I followed the circles of the quarters, then I would get all those little tiny circles, but that's not what I'm following. I'm following that dot that's on this circle. And if I follow that dot that's on the circle, then it would create this big four-leaf clover shape. And so the parametric equations for that big four-leaf clover shape, which is called an epicycloid, is x equals 5 cosine of t minus cosine of 5t, and y equals 5 sine of t minus sine of 5t. So the question is to find the distance traveled by the point in one complete trip. In other words, that means find the whole distance of this epicycloid. Right? Notice here that I could potentially, just by looking at this, you can see it, and we'll show this. If I found this distance right here, then I could multiply that distance times 4, and that would give me the entire distance, right? So that's exactly what we're going to do. So let's notice something. Do this in black. At t equals to 0, what do we get? X is equal to, if I plug in 0, I end up getting 5 cosine of 0, so that's going to be 5, and then I get, so 5 minus 1, which would give me 4, and my y is equal to, it's just going to be 0 minus 0, which is 0. So I get the point 0, 4 at t equals pi over 4, right? So that's this point right here. This is t equals 0. I don't know why I said pi over 4. So at this point right here, that's the point 0, 4, happens at the point t equals 0, right? At t equals pi over 2, what do I get? I get that my x is equal to, this time at pi over 2 cosine 0, so this is just 0 minus 0, which is 0. And y at sine at pi over 2 is going to be 1, so I get 5 minus 1, which equals to 4. So I get the point 4, 0. So that is this point right here. That happens at t equals pi over 2. And on that whole time in between t equals 0 and t equals pi over 4, or I don't know why I keep saying pi over 4. I think it's because I'm multiplying by 4. But in that whole part of the curve from t equals 0 to t equals pi over 2, it's a nice smooth curve, and it doesn't cross itself. The graph doesn't cross itself, so I'm able to find the arc length on that interval. So what we're going to do is use that formula. So to find the total arc length, which is the distance traveled, right? Which is what we were asked to find. We will find the arc length from t equals 0 to t equals pi over 2. And again, that's just that first clover, and multiply by 4. So that's our game plan. Okay, so in order to find the arc length from t equals 0 to t equals pi over 2, I got to find dx dt squared and dy dt squared. Right? So dx dt, what is that? That is the derivative of cosine is sine. So I get negative 5 sine of t plus 5 sine of 5t, right? And dy dt is going to be, if I differentiate y, I would get 5 cosine of t minus 5 cosine of 5t. Right? So now I know my derivatives. I can plug everything into our formula here. Right? So my formula is for the distance traveled is going to be 4 times, right? Why 4? Because I'm multiplying by 4 because of my 4 leaves, right? And it's going to be the distance from 0 to pi over 2 is what we're going to multiply times 4. And then remember, it is going to be the x derivative squared plus the y derivative squared all underneath the square root. So the x derivative is negative 5 sine of t plus 5 sine of 5t squared plus 5 cosine of t minus 5 cosine of 5t quantity squared. And I'm going to take the square root of that. So it's going to be a doozy, right? It's going to be a big one. So first thing I'm going to do is I'm going to square out all of those, that these are 2 binomials squared, right? So I'm going to square them out. So remember, it's the first one squared times 2 times the first times the second plus the second one squared, right? So this one ends up being 25 sine squared t minus 5 times 5 is 25 times 2 gives me 20 sine t sine of 5t plus 25 sine squared of 5t. So that's squaring out the first binomial. Now squaring out the second binomial, I get 25 cosine squared of t minus, again, 5 times 5 is 25 times 2 is 50, so minus 15 cosine of t cosine of 5t plus 25 cosine squared of 5t. Scoot this over a little bit. And then this is all underneath the square root. I'm just going to continue my square root there, dt. Okay, so now we got to do a whole bunch of algebra. So try to keep up here. So I shouldn't have put 20. This should have been 50, right? Okay, so first thing that I'm going to do is pull out a 25 from everything. If I pull out a 25 from everything, I'm going to have sine squared t, and then I would have, so I'm going to pull out everything and I'm going to group things together, right? So grouping things together, we'll do that in orange. I'm going to group this sine t together, that a little bit bigger, this sine squared t together, this cosine squared t together, and then I'm also going to put this sine squared of 5t and this cosine squared of 5t together. And that's because we have the identity sine squared plus cosine squared equals 0, right? So if I pulled out a 25 of sine squared t, I'd be left with sine squared. Then I'm going to pull out, and then I'd have a cosine squared t. Then minus 50 sine t sine 5t. Then I'll go ahead and put the minus 50 cosine t cosine of 5t. Scoot this down a little bit. And then, so I took care of these two terms, and then now I'm going to group my green terms together. So I'm going to group plus sine squared, whoops, and I shouldn't put 50, I should put 25 there, because or actually I should put 2 there, right? 2 there and 2 here, because I pulled out 25, so I should have 2. So I get sine squared of 5t plus cosine squared of 5t. So in this step, again, what did I do? I pulled out a 25 out of every single term, and then I grouped my sine squared t and cosine squared t together, and my sine squared of 5t and my cosine squared of 5t together. Why? Because those are both equal to 1. Right? If I have the same argument of sine and cosine squared, then those are equal to 1. So now, the square root of 25 is 5, so I pull that out front, and then I'd have 5 times 4, which would give me 20 here. 0 to pi over 2. And then now, I get 1 plus 1, so 2. I don't know why I put the square root first. So I get the 1 plus 1 would give me 2 minus sine, or actually I'm going to write this kind of weird, but I'm going to write minus 2 of cosine t, cosine of 5t, minus 2 sine of t, sine of 5t. And again, it doesn't really matter what order I put it in, as long as I keep subtracting. But this is going to be easier to use an identity. So this is an identity that we don't use very often, but it is an important identity. And so this is it's called the sum and difference, right? So this is sum and difference. So this one says that if I have cosine of u times cosine of v, plus sine of u times sine of v, I can rewrite that as cosine of u minus v. All right? So I'm almost there. I can't quite do it yet because I can't quite tell all my negatives. So what I'm going to do here is pull out a negative 2 out of these two terms, right? So if I pull out of a negative 2 there, then I'll be happier with what's going to go on, right? Oops, sorry, I've got alarm going off. So what I'm going to do here is 20, the integral of 0 pi over 2. And now I'm going to 2 minus 2. And then if I pull down a minus 2, I'd be left with positive cosine t cosine of 5t. If I pull down a minus 2 out, this would be plus sine of t sine of 5t dt. This is all underneath the square root. So maybe I should scooch this around for the sake of our notes. This is what we're looking at here. These we can put as brackets maybe, so we keep track of what we're doing, because I forgot a bracket right here, and then we continue on. So now we're going to use this sum and difference formula, right? So what can I do here? In this case, I should write I'm going to use the sum and difference formula right here, right? So in this case, u is equal to, we can always make it the bigger one, so u, because multiplication is commutative here. So I'm going to make u my 5t and v my t. So that means that u minus v is equal to 5t minus t, which is 4t. So in other words, I can take that whole thing and replace it with cosine of u minus v, but u minus v is 4t. So I can replace that with cosine of 4t by this identity. So here I get 20 times the integral from 0 to pi over 2, 2 minus 2 cosine of 4t dt, right? And now I'm going to use another identity, right? This one I'll do, it's one that actually I have given to you guys before in your little trig identities, but this one is the power reducing formulas. So what does this one say? This one says that I can rewrite 1/2 minus 1/2 cosine of 2u as sine squared of u. So again, that's not really what mine looks like. Mine looks like cosine of 2 minus 2 cosine. So what I could do is I could multiply by 2. So again, I have, I'm trying to think, 2 minus q. Yeah. So here I could replace 1 minus cosine of 2u with 2 sine of squared u, right? So this is going to be more helpful because I could factor out a 2 here. So again, maybe I should skip that down and bool out that step right here. This step, I do 20 times the integral from 0 to pi over 2 of, pull out the 2. I'm left with 1 minus, actually 2 stays inside of there, right? 2 and then 1 minus cosine of 4t and the square root dt. Again, I kind of like these as brackets. So now this guy is what I'm replacing with the power reducing formula. But remember, it says 2, whatever, essentially whatever is being multiplied by 2 inside of the cosine needs to be divided by 2, or actually, in other words, whatever is inside the cosine argument, I need to divide it by 2 to be in this new sine thing, right? So in this case, my u is equal to 2t, because if I divide this guy, this argument, by 2, then I would get 2t, right? So this one I get 20 times 0, the integral from 0 to pi over 2 of 2 times, now I'm replacing that with sine, with 2 times sine squared of 2t dt, right? So now 2 times 2 is 4, but then, so I can have a 4 there, but then I take the square root of it and pull it out. So the square root of 4 is 2, so I get 40, the integral from 0 to pi over 2 of the square root of sine squared of 2t dt. Whew, we're getting there, right? So now 40 times the integral 0 to pi over 2 of sine of 2t dt. Finally, now it is a simple integral, right? 40, now I take the antiderivative of this. The antiderivative is negative 1/2 cosine of 2t, evaluated from 0 to pi over 2. So 40, negative 1/2 cosine, if I plug in pi over 2, the 2's cancel out, so cosine at pi minus negative, so plus 1/2 cosine at 2 times 0 is 0. So here I end up getting 40. Cosine at pi is negative 1 times negative 1/2 gives me positive 1/2. Plus cosine at 0 is 1, so I get positive 1/2. 1/2 plus 1/2 is 1, so I get 40. And remember, I already multiplied by 4 here when I did all this. So I got all 4 of those clovers for my distance traveled. So this is my final answer. 40 is the distance that I've traveled. All right, so that's the end of this video. Thank you.